and we're going to take a look at question number 4, proving that vectors are linearly independent or not. So apparently the solution is yes, they are independent. Okay. Apparently they are independent. Okay, so are these vectors linearly independent? The answer is yes, but let's see why. So how does this work? If we take A, let's actually go to black here. It's Black History Month, right? Let's do this. Let's do this proper. So A times 1 plus 3 plus 2 times, B times 3 to 9 plus C times 5 to negative 1. And we set that equal to the 0 vector. And then the idea is to collapse the left-hand side and see what kind of information comes out of the left-hand side. So we should get a 3 vector on the left-hand side that looks like A plus 3B plus 5C. In the second component, 2A plus 2B plus 2C. And the third component is 3A plus 9B minus C. And so this gives us a linear system for us to figure out what the values of A, B, and C could be. So we have, each one of these is equal to 0. So let's go ahead and convert this into a matrix system. This is going to be homogeneous. So we have 1A, 3B, 5C, and 0. And then we have 2A, 2B, 2C, and 0. And then 3A, 9B, negative 1C, and 0. So because we know this is a homogeneous system, I know that it's always going to have at least one solution. So A equals 0, B equals 0, C equals 0 is always a solution. What we're checking for is if there is a non-trivial solution. And if we find a non-trivial solution, then we know that these vectors are dependent on each other in some kind of way. So what we really need to do is find the reduced row echelon form of this 3x3 matrix. If it is anything but the identity matrix, then we have a non-trivial solution. All right. So it's a homogeneous system. I don't actually need the augmented part because we're always going to have zeros over on the right-hand side. So let's just see what the reduced row echelon form of this particular matrix is. We already have a leading one, and then we'll make our conclusion once we get there. So row 2, let's take away 2 row 1s, and then let's take row 3, take away 3 row 1s. Okay, so row 1, no change. Row 2, we're going to subtract 2 copies of row 1. So 2 take away 6 is going to be negative 4. 2 take away 10 is negative 8. Nice. And then 3 take away 3, 9 take away 9. Uh-oh, drum roll. Negative 1 take away 15. Oh, phew. Negative 1 take away 15. So that's negative 16. Then we can take row 2 and divide by negative 4. And we can take row 3 and we can divide by negative 16. This should be fine. I'm looking at this and going, hey, man, this is going to be great. So 0, 1, 2, 0, 0, 1. So yeah, this is going to have only the trivial solution because now we can roll through these other elementary row operations to kind of get the job done. So let's take row 2, take away 3 row 1, take away 3 row 2s. And let's do row 2, take away 2 row 3s. And so 5 take away 3 is 2. So the last thing we need to do is row 1, take away 2 copies of row 3, and we'll get our reduced row echelon form, which happens to be the identity matrix. So we have full rank. Since we have all 3 leading ones, we know that there is only the trivial solution to our homogeneous system. So this means that these vectors are linearly independent.